Okay, let's do a very simple force question. This is number 15 from the week 2 study guide. A boy pulls a 150 kilogram sled across the ice using a force of 20 newtons. What is the acceleration of the sled? So, pretty simple question. We'll draw a very quick and easy picture. Um, and yeah, this is how I draw. So, there you have it. So, here's our sled. Here's our sled, and it is getting pulled across some ice by this kid who's pulling the sled, and he's pulling it with a force of 20 newtons. And the sled itself weighs, or it has a mass of 150 kilograms. All right, so this is the question setup. That doesn't really look like a sled. Let me give it an outline. There. There, this is better. Now it's a sled. All right. So here's our sled. This kid is pulling it. The sled is 150 kilogram mass. He's pulling it at a force of 20 newtons. Remember, according to Newton's second law, force is just simply mass times acceleration. So we're looking for the acceleration of the sled, which means we need to rearrange this equation. So we're going to divide both sides by m to get rid of m, which means acceleration equals force over mass. Well, remember, force is 20 newtons, mass is 150 kilograms, so acceleration equals 20 newtons divided by 150 kilograms, which equals 0.13 newtons per kilogram, which equals 0.13 meters per second squared. So that is the acceleration of the sled. You might be wondering how we got from 0.13 newtons per kilogram to 0.13 meters per second squared. Well, they're the same thing. It's just a matter of units. So remember that 1 newton equals 1 kilogram times meter per second. This is the units of a newton. So if we have 0.13 newtons per kilogram, that actually equals 0.13 kilogram times meter per second squared over kilogram. So the kilograms cancel, and what we're left with is 0.13 meters per second squared. Okay, so that's the acceleration of the sled. Now you might be asking, well, is that a lot? Well, keep in mind that 0.13 meters per second squared means that the velocity of the sled is 0.13 meters per second every second, which means that the first second the sled is being pulled, it's going at 0.13 meters every second. Then after 2 seconds of traveling, the boy's going faster. So now it's 0.26 meters per second. Then after 3 seconds, it's 0.26 plus 0.13, right? Because we're going 0.13 meters per second faster every single second. So after 1 second, the sled is going 0.13 meters per second. After 2 seconds, the sled is going 0.26 meters per second. After 3 seconds, the sled is going 0.39 meters per second, and so on and so forth. Eventually, the kid's going to get tired. He's not going to be able to maintain this force of 20 newtons pulling on this sled. So eventually, he'll reach a point where he's not going to have any acceleration. He can still have if he has no acceleration, he can still have a velocity. The velocity just won't be going any faster. So if there's zero acceleration, and let's say he's going 0.39 meters per second, but there's no more acceleration, that means he's just going to be staying at 0.39 meters per second. So the force is just going to be zero, because if his acceleration equals zero, remember, force equals mass times acceleration. So if A is zero, then F is going to be zero as well. If there's no force, then what's going to keep this sled going is just simply the slickness of the ice, because friction isn't that much. There is a friction, so the sled will slow down over time. and the velocity will start to go in the other direction until eventually it comes to a complete stop, which is zero. But once the acceleration is zero and the force stops, then the sled will go because it's on ice, but it will start to slow down. Okay, that's it. If you have any questions, please let me know. Throughout the week, I'll be presenting more and more challenging force equations, which is going to lead us, or I should say force questions, which is going to lead us to the examination. But really challenge yourself. Take a look at those study guide questions. Try your best. If you run into any difficulties, please let me know, and then we'll help you out as best as I can. All right. Take care and talk to you soon. Bye-bye.